Welcome to the October 29th, 2021 online math tutoring stream from mathcelebrity.com. Let's get things started. Raise r to the 8th power, then find the product of the result and 3. So this is an algebraic expressions. We're going to take this in pieces. Raise r to the 8th power means we raise r with an exponent of 8. So we got r raised to the 8th. Then find the product of the result in 3. The product of the result in 3 means we multiply r to the 8th by 3. We got 3r, 3r raised to the 8th. And that is our algebraic expression. We also had exponents. If you're new to the stream here, I do these problems in the community page or the forum, not our main page. And I tag these because if you to mathcelebrity.com/community, you could see these problems and I tag them. So you could click, say, algebraic expressions, and you'll see every algebraic expressions we've ever covered. So now you know why I tag them. All right. Here's another algebraic expressions. This one's pretty easy. Product of r plus 7 and 4. So r plus 7 means we add 7 to r. r plus 7 plus 7. And then the product means we multiply the expression, and there's a key word there, r plus 7 by 4. 4r plus 7. Okay, that's our answer. So that's 2 in the bag for today. Next, this looks like a cost function. A baseball park charges $4.50 per admission ticket. The park has already sold 42 tickets. How many more tickets will they need to sell to earn at least $4.41? Let price of each ticket be T. We're given earnings equal park sold 42 tickets, 450. I'm sorry, let the number of each number of tickets above 42 BT. We're given 450 times 42 tickets have already been sold, plus 450T equals 440, or I'm sorry, greater than or equal to 441. What did I just do here? The phrase at least, so I want to space this out here. The phrase at least means greater than or equal to, so we have an inequality. Earnings equal price times quantity. A few things to note on this problem. Let's just do that so you can walk through what we're doing here. Okay, so we've already sold 42 tickets at $4.50. Let me go off camera and use my calculator. We get $189. So we got 189 plus 4.5T is at least or greater than or equal to $441. We want to solve this inequality for T. And what I'm going to do is go off camera real quick onto the Math Celebrity calculator. Give me a few seconds, and I'm going to paste all this in for you below. Here we go. Ready? Here we go. Okay. So I took this inequality, dropped it in our math engine, grab the work and the answer, and I'm pasting it back here so you could see. We want to solve for t in the inequality 189 plus 4.5t greater than or equal to 441. So first thing we do is eliminate the constant on the left side because we want to isolate the t term. Second is we divide each side by 4.5. Why? Because we want to isolate t and get rid of the coefficient. So when we do that and we cancel the 4.5s, we get this as our answer, which means they have to sell at least 56 tickets or more to get their total revenue from the problem. So we had an algebraic expression and we had an inequality. That's that. All right, moving on. I'm going to save a few of these for later because I might have to look up something. A tortoise is walking in the desert. It walks at a speed of 5 meters per minute for 12.5 meters. For how many minutes does it walk? Distance formula D for a rate R and time T is D equals R times T. What are we given here? We're given D equal to 12.5 and T or R equal to 5. So we have 12.5 equal to 5R, or I'm sorry, 5T. Solve for T. Well, if I divide each side of the equation by 5. So first thing I'm going to do here, I'm going to reverse this. Why? Because I like my variable on the left side. These two things are exactly the same, but since we read left to right, I like to have the variable like this. I'm going to drop this down here. I'm going to divide each side by 5. Cancel the 5s on the left side, and we get t equal to 2.5. So it walked for 2.5 minutes. And the key here is the distance equals rate times time formula. If you're in pre-algebra, drill that formula into your head because you will see these problems over and over and over again. We did rate, we did time, and we had an equation. Right. Nice work. Let's go to this one. 17 decreased by 3 times d equals c. 3 times d means we multiply d by 3. We got 3d. 17 decreased by 3 times d means we subtract 3d from 17. So we got 17 minus 3d. The word equals means an equation. So we set 17 minus 3d equal to c. 17 minus 3d equals c. And this, my friends, is our answer. Those are algebraic expressions. All right, moving on. What do we got here? Let's come down here and mix it up a little bit. All right, we got the square of the sum of x and y is less than 20. The sum of x and y means we add y to x plus y. The square of the sum means we raise the term x plus y to the second power. Now, when we do this, we have to wrap it in parentheses because we are raising the whole thing, not just x or y, but the sum. The phrase is less than means an inequality. So we write this as follows. We're going to take this term as our left side. Less than is this symbol. It's not less than or equal to, it's less than 20. That's this parentheses. So this is your final answer. As I tag this, I'll give you a few seconds on the screen to take it all in. So we had an inequality, exponent, and then our final algebraic expressions. Okay. Dunder Mifflin. I know we have some Office fans who use our site, so we'll do this one. Dunder Mifflin will print business cards for 10 cents each, plus setup charge of 15. Wareham Hogg offers business cards for 15 cents each with a setup charge of 10. What numbers of business cards cost the same from either company? Let B be the number of business cards. So declare variables. Let's do this. Isolate that out. Set up the cost function C of B for Dunder Mifflin. C of B equals number of, or I'm sorry, 10 cents times B business cards plus setup charge. So before I do that, cost to print each business card. I don't want to jump ahead. Okay. We're given the cost to print each business card 0.1 or 0.10, however you want to write it, B, plus a setup charge of 15. Okay, so we've got Dunder Mifflin and their cost. We want to do the exact same thing for Wareham Hogg. Wareham Hogg. So let's rewrite this. Wareham Hogg. Same equation, cost function, cost to print each business card times B business cards plus setup charge. But this time, Wareham Hogg charges 15 cents and their setup fee drops to 10 cents. Okay, we've got two vital pieces of this problem. Now let's bring it home. What numbers of business cards cost the same from either company? The phrase cost the same means we set both C of B equal to each other and solve for B. Okay, so we take this, we take Dunder Mifflin's and set it equal to Wareham Hogg's, and we solve for B. What I'm going to do is I'm going to go off camera real quick onto the Math Celebrity Math Engine, type this in, I'm going to grab all the math, and I'm going to bring it back, and we're going to get looks like we're going to get a nice round answer. Okay, so here we go. We left off here. Starting here is the math work from the Math Celebrity site. As you can see, we first eliminate constants. If you've been on our stream before, you're going to notice we're doing the same thing over and over again. We've got a system for this. If you recognize the patterns in the problem, you can follow the system and you'll never go wrong. Once we get the b's on one side and the constants on the other, we have a nice, easy solve for b. So we're going to divide each side by negative 0.5 to get rid of this, and we get b equal to 100. So 100 business cards is the answer to make the cost function of Dunder Mifflin equal to Wareham Hogg. So this was a big cost function problem and equation because we set them equal to each other. Right. Penguins. My son loves penguins, so this will be fun. A zoo has 15 emperor penguins. The emperor penguins make up 30%. Let me get rid of this stray comma that they put in. 30% of all the penguins at the zoo. How many penguins live at the zoo? Let P be the total number of penguins at the zoo. We're told 30% of P equals 15. Since 30% equals 0.3, we have 0.3 P equals 15. Okay. Pop this in here. And I'm going to paste in the math. I'm off camera. Just give me 1 second to paste this in. We got this. So if we're solving for P, we want to get rid of the 0.3 on the left side. To do that, we divide, simplify, and we get 50 total penguins at the zoo. So what this problem really asks is 30% of what is 15 and what is the total number of penguins? That's how you can think of these problems. All right. Put a wire here. 98-inch piece of wire must be cut into 2 pieces. One piece must be 10 inches shorter than the other. How long should the pieces be? Key phrase in this problem is 2 pieces. Why? That's good because you only care about 2 pieces. Whatever's cut on one side, the other side is going to be the full length minus that length, and that's it. Given the following. Let the short piece be S, so we'll declare variables. Jumping ahead here. Short piece length be S. Long piece length be L. We're given the following. We're told that one piece, so S equals L minus 10. Shorter, it's 10 inches shorter than the other. And we also know S plus L has to equal 98. Why? Because there's 2 pieces. And I'm going to put because the 2 pieces add up to 98. That's a key there. This is the shorter than the other. Okay, we're in a really good spot here because S is already solved for. So substitute equation 1 into equation 2 for S. So let's pull down equation 2 here, and we're going to take L minus 10, put it in for S. We get group like terms. We get 2L minus 10 equals 98. Now what I'm going to do, I'm going off camera real quick, going to the math engine so I can grab this math for you. Hold on, almost there. Okay, we're back. Here we go. So 2L divided by 2 equals 108 divided by 2. L equal to 54. I'm going to bold this because they want to know the length of both long and short. Okay. To solve for S, we substitute L equal to 54 into equation 1. S equals L minus 10, but L is 54. S equal to 44. So we have our two segments or pieces. The short one is indeed 10 less than the larger. That was the first check. We want to check to make sure that in fact, let's check our work here. Check our work. The longer or shorter piece is 10 inches shorter than the longer piece. Since 54 minus 44 equals 10, that's the first check. Second check, do both pieces add up to 98? 54 plus 44 question mark 98, we don't know. When we add these two together, we do indeed get 98. So our work is checked. Add simultaneous equations, and that's the answer. So long piece is 54, short piece is 44, and we are done. All right. On. Let me check the chat real quick and make sure. Yep, we're good. Okay. A $650 television costs $702 after sales tax is figured in. What's the sales tax percentage? Calculate sales tax amount. Sales tax amount equals total bill minus original cost. The total bill was $702, which we're given, minus 650. Sales tax equals 52. That's the first piece that we need. Now calculate sales tax percentage. Sales tax percentage equals sales tax amount, which we just calculated, divided by original cost. And we're going to multiply this by 100%. That asks for a percentage. All right. So we got this. I better do a multiply here, so that makes sense. Great. We got $52 sales tax amount divided by 650. Let's see what that is real quick off camera. Outstanding. Nice round number. Times 0.08. And then we get sales tax percentage equals 8%. Hold that because that's our final answer. We had two parts here. We want a sales tax amount because the sales tax amount is used in the original cost. And that's how you get the sales tax percentage, which of course was 8%. We got sales tax percentage. That's that. All right. Let's keep it going. Julia spends $1.75 on gas for her lawnmower. She earns $16 mowing her neighbor's yard. What is Julia's profit? Profit equals revenue minus cost. Profit equals $16 minus 175. Profit equals $14.25. Now, if I move too fast for you, this is the only thing you care about. If you're in economics or finance and you get asked these problems, drill this formula into your head, add it to a note card, and carry it around because you'll see this over and over again. Profit is revenue minus cost. So it's the leftover. You earn some money at a job, you earn some money in your business, and then you've got cost. Once you take a cost away, profit is what you get to take home. And in this case, it's $14.25. We get profit, cost, revenue. Boom. All right. This one I was going to save for tomorrow, but let's take a crack at it. Van needs to enter a formula into a spreadsheet to show the outputs of an arithmetic sequence that start with 13 and continues to add 7 to each output. For now, Van needs to know what the 15th output will be. Complete the steps needed to determine the 15th term in the sequence. All right, starts with 13 and adds 7. I'm going off camera here, by the way, because I may be able to do this without. Starts with 13, adds 7. Okay, great. First term is 13, adds 7. Expand the series. Okay. I'm going to paste this in so you could start reading this. I got to go back off camera again. A1, A sub 1. And the 15th term is going to be, all right. If n equals 15, then we plug it into our formula above into our explicit formula above. Now I want to stop here because in case you're new to sequences or you're wondering what the heck I'm doing, if we start with a constant term and we change by 7, that's called an arithmetic series or sequence. So I'm going to italicize this because it's a constant different or a constant addition for the next term. So it's something plus the last term, and then you add in whatever term was before it. In this case, a sub n is 13. A sub 15 equals 13 plus 7. 7 times 15 minus 1. A sub 15 equals 15 plus 7 times 14. A sub 15 equals 15 plus 98, right? 28. A sub 15 equals 98, 108, 113. Okay, let's go back over what just happened. We're told it's an arithmetic sequence, which is good. But if we weren't and we're told we start with 13 and we continue to add 7, this is a key phrase here. That's a dead giveaway that we have an arithmetic sequence. Now, the first thing we do, we could start with 13 and keep adding 7, right? If you want, and just do it 15 times, but that gets tedious. Arithmetic sequences have a special formula, which is this. A1, of course, is your first term, which was 13, and then you plug in n and multiply by d. D is the change. So the common difference is 7. Once we have that, we can just plug in whatever n we want, in this case 15, plug and chug, evaluate, solve, and we are done. So that's it. I want to thank everybody for watching the stream, and I will see you on the next